Hello everyone. We, the Faculty of Mathematics Wing, KCG College of Technology, are here to brief you the application of mathematics in engineering fields. Any physical structure or body can be converted into mathematical equations. In automobile field, the complete car body can be converted into mathematical equations known as mathematical modeling. The behavior of the vehicle can be predicted using mathematical equations.
In this world, everything is mathematics, from the ticking of time to the rhythm of our heart. As Pythagoras rightly said, there is geometry in the humming of string and music in the spacing of spheres. Mathematics plays an amazing role in each and every field of study, and among them, engineering is one of the important fields. But the car of engineering cannot run without the wheels of mathematics. But aerospace is the only engineering branch which make wings out of it. Mathematics is not used in the form of hand-to-hand calculation, but through many softwares. The space around Earth is getting more and more crowded. The solution for these advanced aerospace problems like space debris and satellite collision can also be accomplished with the greatness of mathematics and proper planning.
I'll be sharing few interesting applications of mathematics to civil engineering. Civil engineering being predominantly based on shapes, structures and measurements, it heavily relies on certain mathematical disciplines including geometry and symmetry, calculus, differential equations and linear algebra. Here we take a look at few historic monuments in which geometry plays a key role. For instance, the small fountain heads in the front divides the Taj into two equal and identical halves to mirror each other. The fascinating fact is that the symmetry is not restricted to the Taj Mahal alone, as every other construction in the complex maintains the same symmetry and balance. Another beautiful example of mathematics in construction is the golden ratio. The first historical evidence of the golden ratio dates back to 447 BC in the construction of the Parthenon in the ancient Greek Empire. Other significant structures claimed to have used this ratio are the Notre Dame, the Great Pyramid of Giza, the UN Secretariat building, and even Taj Mahal and Eiffel Tower are said to be golden ratio proportional.
Hi, I'm Dr. M. Geethalakshmi, Assistant Professor in Mathematics, KCG College of Technology. I'm going to discuss about the applications of mathematics in computer science. Mathematics is the foundation on which computer science is built. In fact, it can ever be said that computer science is a subset of mathematical sciences in general. You ever heard of logic notation, set theory, combinatorics, graph theory, probability, algebra, number theory, etc. Don't be overwhelmed. These are all a part of discrete mathematics and also a basic foundation for programming and computer science. A prime example of this is algebra. While Boolean algebra is used in logic gates, relational algebra is used in databases. In case you need another example, number theory has multiple applications in cryptography and cryptanalysis. Where did you first use an algorithm? It was not the computer science class, actually it was a mathematics class. 2 plus 3 equal to 5 is a basic algorithm you learned in mathematics class that demonstrates the sum of 2 and 3. Mathematics is actually very important in learning the basic usage of algorithms that are utilized in advanced form in computer science. In general, the basic knowledge of limits, differentials and integrals is used in many situations when you try to solve a technical problem. For example, if you are building a controller to keep a room at a particular temperature, your algorithm will need to compute the derivative and integrals of your room temperature over time. Another example, to train an artificial neural network, you need to compute the derivative of the error with respect to the weights. Come, let's enjoy the magic of mathematics in computing field.
Modern technology would be unthinkable without mathematics. Of course, the relationship is reciprocal. Mathematics also need technology. Information technology has strong influence on many aspects of our everyday life. Application of math in information technology is nearly endless. Some areas of information technology have significantly more math. For example, video game development with various simulations and graphics require more math application than software development in general uses. The fundamentals of information technology operate on logical system where math is intrinsic to their operation. Mathematical reasoning is important for most problem solving, especially software system development. Discrete mathematics, elements of graph theory, probability and statistics are directly useful in information technology, especially those who are looking for higher levels of IT job.
Some of the applications of mathematics in the field of engineering, more precisely electronics, communication and engineering. These technicians need more mathematics including complex numbers, trigonometric, elementary geometry, elementary statistics, linear algebra and calculus, so on. So the basics of circuits are in linear algebra and are used in complex network analysis. In real life, we will find many situations where we need to solve hundreds of equations to find current in a circuit. Moreover, it has huge impact in control systems, robotics, circuits and power systems, etc.
As a mathematical person, I can proudly say that mathematical is the queen of all sciences. And also we can say that mathematics and engineering are like bones and nerves of our body. So maths and engineering cannot function without one another. Electrical engineering is the most heavy math application engineering field. Unlike civil or mechanical engineering, nothing is there visualized physically in electrical engineering. Hence, to understand the various behavior of circuits and also make things simpler, the knowledge of mathematics is very essential. Now, I am going to list out some of the applications of mathematics in electrical engineering. In circuit theory, to face circuits involving capacitors and inductors load, linear algebra and ordinary differential equation are used to solve these circuits. The concept of complex numbers are used in describe RCL behaviors. Vector analysis is the most important part of electromagnetism.
Now we are going to see about the application of mathematics in fashion technology. In any manufacturing product, no two articles are perfectly alike. It is impossible to find two knots of the yarn having exactly the same size, color, strength, length, evenness, etc. It is because of the raw material. The cotton itself is a raw material. It varies from fiber to fiber within a bale to bale, and from season to season. So the quality of the product in each process, it varies according to the variation of the raw material used. So these variations are often occurring problem in textile. To overcome these variation, mathematical calculations can be used. So when I talk about color matching is not only to obtain a perfect shade of the color, but also to analyze different method to obtain the color matching at minimum cost. The matrices and factorials are used to attain the target.
Mathematics, or particularly applied mathematics, is widely used in every engineering fields. Yes, mathematics is considered to be the base of all engineering courses. There are vast applications in each branch of engineering. In order to be a good engineer, one should be capable of handling mathematical problems efficiently. As a mechanical engineer, you will be required to combine your skills, knowledge and creativity in order to bring an idea to life and make it a reality. Yes, your knowledge of calculus helps transform an idea into life. For example, when we design a pump needs calculus, we must design the pump to properly work with the required flow rate necessary. Finally, I'd like to say engineering plus mathematics equal to everything. Engineering minus mathematics equal to nothing. Thank you.